Thank you, Professor Adin. And thank you everyone for joining today. That was a great introduction. So it's sometimes it's interesting hearing your bio read back to you. I've done a little extra effort in my slides today for people that are watching and following along. Almost every slide you're going to see today will have a QR code. And if you're ever interested in learning more about what I'm working on, the projects or my background as I'm talking, or if you want to make a connection on LinkedIn, or you think that we should talk about, STEM education or how assessment works inside engineering education specifically, feel free to reach out to me. So my contact information is here, but that QR code will also bring you to my LinkedIn page where you can look at my research and my activities. So please do follow along with me there. As Professor said, I am currently in charge of a few initiatives at Mathworks related to teaching and learning. But what we're going to focus on today is the concept of auto-grading. And we're going to define what that is, and we're going to talk more about specifically the use case of auto-grading for MATLAB code. MATLAB is the flagship product developed by Mathworks. If you are a professor today in higher education who is teaching some sort of science or engineering curriculum, likely you know what MATLAB is, whether or not you use it in your classroom. And if you are in certain disciplines, such as mechanical engineering, electrical engineering, and computer science, you probably are making heavy use of MATLAB. Mathworks, we sort of enjoy a relatively large market share of the use of MATLAB in scientific modeling and computing worldwide. But MATLAB in education is very pervasive. And what we're going to talk about today is, as we talk about the theme for this conference, the challenges faced with engineering and online education, specifically our solution for solving some of those challenges that are related to our other products. So this is our agenda for today. While we are scheduled for 2 hours, we may not use the whole 2 hours. It's really going to depend on you all in the audience. And as the professor said, we would love it if you could put the chat messages in and type them in. We are going to try to respond to them as we do the presentation. I like nothing more than to answer your questions in the context of the slide where you had the idea or the question or the discussion. I'm very comfortable sort of weaving in a nice, thoughtful response to your questions as we go. We will also have some time at the end. I'll have a dedicated slide for wrapping up questions at the end or ideas that you may have. There's also going to be a lot of resources shared with you, and a lot of pages are going to have the QR code in addition to links, so that you can sort of take a screenshot or take a picture with your phone or go to the link as we talk, and you might learn some things at those links as we go. So the workshop aspect of this is really you all in the audience sort of paying attention, following along. Don't just listen to me, but explore the things I'm sharing as I share them. They're relatively simple, but powerful resources. And as you have questions about those resources, bring them back into the chat, because I want to make sure that those resources are resonating with you as we have the conversation. I'll be doing about 20-ish slides of presentation to actually set the stage in the context of this agenda. But really what I want to get into is showing you how to do this, actually going into a real course, actually showing you how to do the act of auto-graded programming assignments in the context of engineering education, using the same tools you might use yourselves if you're teaching an online course. And I want to spend most of the time in there today. And so we're going to have a good bit of time for product demonstration. Also, we're going to be talking a little bit about different use cases for both instructors and students. There'll probably be a nice break point before I switch context there to take a break. 2 hours is a long time to sit. I don't really have enough content to fill 2 hours anyway, so we might find a nice stopping point after the hour point to take a break. So that's sort of how we want to structure the discussion and the time today. So the agenda, just to set the stage, what is auto-grading? What challenge is that meant to solve with respect to programming as a learning activity? The experiential learning activity of programming has very specific challenges for students. more so in an online teaching forum. So define auto grading. What are the benefits of auto grading, and then pivot to say specifically about auto grading the type of programming code, which is MATLAB code or script. And you don't have to be a MATLAB user to understand these concepts and these challenges. It will be helpful if you do. I'll be talking a little bit about some of the specific things that you can use our product for auto grading for. The product you're going to hear me talk about, MATLAB Grader, it was in the introduction for myself. That is the brand name of our solution for auto grading programming assignments based on MATLAB code. I'm going to briefly talk about how you get access to that. The good news is, for today's workshop and for anyone worldwide, MATLAB Grader is free to use if you have a MATLAB license. And MATLAB Grader really isn't useful for you unless you already have a MATLAB license. There's no reason to use MATLAB Grader in your teaching if you don't already teach concepts using MATLAB in your classroom. So you probably already have the licenses you need. You can just add in MATLAB Grader, and we'll talk about how to use that, how to log in. And part of the workshop today, before I get in the demo, will be to encourage you to actually try logging in, follow along, open another window up on your desktop, your laptop, and follow along with us. At a minimum today, you should get a good orientation to how that product works for an entire life cycle about creating automated assessment and then delivering them to students and reviewing the results and the analytics and doing sort of a course evaluation based on your student performance in the auto-graded assignments. Today's demo, you're going to get a wide view of that. You're going to want to go in and try it for yourself after today's workshop to see if it would work within your instruction. So we've also got some really great user stories and some examples of other faculty that have used this product successfully in their courses, and a whole bunch of links and resources I'm going to share with you, all with QR codes that you can look at today to get started hands-on yourself with the product. So you might be able to do a little hands-on today if you're following along. I'm going to go relatively slowly paced through the product, but if you didn't get a chance to log in on today's workshop, you'll have everything you need to try this on your own going forward for your own teaching practice. And then at the end of this, we'll do some reasonable time for questions and answers if I have not been able to answer your question during the actual presentation. Okay. So what is auto grading? It's very simple. It is a method by which the instructor or the grader or teaching assistant, the person that does the grading, we'll call them the grader, lump all those actors together into that persona, the grader. We need to save their time. You have teaching assistants and limited resources and staff that probably spend a lot of time manually grading assignments. And when you're manually grading programming assignments, there is a lot of effort that you're expending to actually work on those assignments. In our research, we have found if I'm grading a programming assignment where I'm looking at the code submission, so I put a prompt in front of the student and they answer in the form of some sort of script or programming code, whether or not it's compiled is sort of irrelevant, but they answer in the form of code. In a manual grading situation where someone's reading their code or running their code and looking at the results and interpreting the results, it usually takes, and if the class size is anywhere between 50 to 100 students, where we find most introduction programming or most programming courses tend to be the largest courses in the department at the university, because they're very large foundation gateway courses that lead you on to other science and engineering pathways. We find that programming courses where there's grading going on tend to be very large. And because of the class size, because of the sheer number of students, because of the manual intensity of the work of the act of grading, it could take you potentially weeks to turn around the feedback on those assignments to the students. And programming is a very complex art. It has a lot of skills that there are a lot of prerequisite skills that build upon each other, where if you have bad practices or you learned things incorrectly, to move on to the next learning objective or to move on to the next bit of skills development, if you don't have a base understanding of the previous concept, it makes it very difficult. So before you can introduce for loops, you have to have a good understanding of a while loop, as an example. If you haven't received feedback on as a student, as a learner, if you haven't received feedback on your previous assignment, before you move on to the next one, you might be reinforcing some bad habits, or you might start to get lost or lose momentum in your course and mastery of the content. So you're already on the path to working on your next homework and submitting the next homework before you've received the feedback. And because as a learner, you're already working on the next assignment, are you really going to spend the time to review the written or manual feedback from the grader on that assignment? There's a question there. Some people do, some people don't. But there's less opportunity to do that if you're already moving on to the next activity. So when we think auto grading, we want to change the paradigm. We want to change the workflow. We want to talk about what it means to give instant feedback to the learner at the moment in time they submit their homework for grading, so that they can iterate on their solutions. One of the other problems with traditional grading is you try to do the project, you think it's correct, you submit it to the instructors, but you don't know whether it was correct or not, and you don't know kind of when you're done. With auto grading, you have the ability to do a feedback loop of iterations in real time. Submit lines of code, get immediate feedback. That feedback might tell you that you're on track or not. Improve your output, improve your programming skills, learn as you go in sort of a formative assessment methodology, and then resubmit that homework, which should be correct. And the thing about auto grading is, if implemented properly, students should know whether before a deadline of an assignment, whether their work was correct or not. So they know when they're done, they know when they've met their objectives. If this were a handwriting assignment or any other sort of written work, there might be a rubric that they can evaluate their work against to find out whether they've met the learning objectives that were meant for that assignment, to prove mastery of those objectives. With auto grading, you can create an environment that automatically gives that type of feedback. So definitively, you know whether you met the objectives or not. You know you're going to get 100% on that assignment. And so I'm spending a lot of time on this because when you see our implementation of this in a product, I want you to be thinking about the theory of auto grading. What does it mean? Who is it for? And I sort of define that in this way. Like, think about what a typical programming assignment looks like. And this is one that we have seen time and time again in our customers in these large introductory intro to programming courses. And these are gateway courses where people will go on to aerospace engineering as equally as computer science or mathematics and statistics or finance. And in this case, it's the traditional method of delivering assignments to students to begin the work is to give them a PDF file with a prompt and description of what to do, and then maybe some courier font styled text in this PDF to bring their attention to what parts are code versus just informational text. And there might be a whole bunch of instructions saying, now go to your programming development environment, in this case, MATLAB, and go do something, and then come back and somehow get the files to the teaching assistant. So package them up, zip them up, email them, upload them, whatever it is. And then, hope and pray a little bit that when the grader gets those files, they will compile, they will run, and they will see the same thing that you saw as a learner when you created them. That's the current state of the art of programming assignments for most people. What we're saying is, take that same content, take that same prompt. In this case, it's about a Leibniz series, a type of convergence series that's pretty common in mathematics. And you can see here on the left, it's the same problem, but now on the right side, I actually have the entire problem title, description, the place where the student's going to submit their code, the results of the assessments as to whether the code is correct or not, all in a web-based online application that's available on both desktop and mobile devices, and which we're going to learn later today integrates into the learning environment so that the grades automatically post to the grade books. There's no reporting overhead. There's no other management aspects. That the environment of delivering the assignment to the students and getting the response back from the students is in the same environment. And this is this act of conversion of your traditional assignments, the auto-graded assignments, is where most of our customers spend their time. There's a lot of fun memes where you can see, developers saying, I wrote a script to do a very common task, and I spent a lot of time writing that script, but once I built that script, it was automated and I could just push a button and I had no overhead, no additional effort going forward. The same can be said about auto grading. There will be an initial investment of time and energy to modify and convert and migrate your traditional assignments to an auto grading format. You will have to learn the auto grading tool. You will have to learn how to declare whether the student's work is correct or not. You might have to do some rather relatively straightforward formatting of images and equations and code examples, or provide data files and data sets, as opposed to with links or zip files or downloadable things. You might have to put them in line to the solution. That's all initial investment. Once your assignment has been created, though, that's when the power of auto grading really kicks in, because from that point forward, you could teach that same assignment that you used to teach to 10 students. You can now teach it to 1,000 students and have no effort as an instructor besides looking at the outcomes, looking now, instead of spending your time grading, now redirect that attention to looking at why students are getting things wrong. What are the patterns to why, the assessments that are failing? Look for meaning in their solutions, and then redirect their energy in the form of office hours or redirection. That concept is where you should be spending your time. Once you've gotten over the initial burden of the conversion, you will have the extra time to do that. And that's again the why people do this. So let's talk a little bit about that. Why? Well, you have staff, yourself as an instructor. If you're blessed enough to have a team of teaching assistants or graders, amazing. Not everybody has that. And there is a reduction in their cognitive burden from managing just the basics of running a class. That will be reduced if you don't have to manually grade assignments. Also, it's consistency. When you're manually grading students' code, even the graders can make mistakes. If they're following a rubric, there's some subject to interpretation if it's not explicitly tested in an algorithmic way. And so when you're teaching large cohorts, you want consistency in your grading. You might have policies for grading. You can encode the policy into an algorithm, which implies it equally in consistency. It's great for proving for accreditors and others that you have consistent standards when it comes to assessment. Also, accessibility. The students, when they can log in anywhere, anytime to do their assignments, and when they log in, all the files are there waiting for them. They don't have to worry about getting software installed on local machines. They don't need to worry about where the files were. They don't need to worry about purchasing extra materials. It's all there in one location. So the students can complete those assignments at their convenience. And this is true whether they are working individually or in groups. They're all going to be looking at the same content. And so there's some really good benefits there for them around that convenience issue. And then I mentioned it earlier, but one of the main benefits, and I'm all for these items, but this one specifically came out of the research. There was actually one of our teaching teams that we support at Mathworks published a research, the citations at the bottom. They found that there is a model of continuous improvement that is directly transferable to professional engineering and computer science careers, that you learn about this continuous improvement of getting to zero defects and improving your code based on the results of analytics and output review or pair type programming. Those sorts of concepts really they're used in industry, and by using an auto grading solution in your academic work, you are learning those behaviors that are very much valued in industry. But we use those behaviors at Mathworks when we develop our products. So we like it when people are exposed to those sorts of models of taking instant feedback and then doing multiple attempts. I also say it this way: if you're teaching an exam, we'll talk about this a little bit. Auto grading can be used for both low stakes, assignments and homework, or for practice, medium stakes, sort of formative assessments, end of week quizzes and everything, and also summative assessments, final exams. Automated grading can be used for all those things. But it's important as instructors that we realize in the real world, I'm using air quotes when I say real world, in industry, real world, when you go to your career, whatever you want to call it, it would be a very weird environment in the real world if every time a programmer did a project, they wrote code, did not actually get feedback on it, and then put it into a production system. When we teach courses and we have programming assignments, it sounds weird to me as an educator to think that we would limit their submission attempts, we would give them no feedback and just grade them on code that has never gone through any sort of code analytics or analyzers or given any sort of feedback to allow them to improve their solution, because you wouldn't want them in industry to ship untested code into production. Why would you then want to encourage that behavior and give no feedback to students in exams? So even though traditionally speaking, because of the reality of traditional grading, where you might have people handwriting code on a piece of paper and handing it in, and they only get the chance to do it once, they don't know if it compiled or not. Would you hold them accountable if they left out, and I'm going to use a very MATLAB thing, if they left out a semicolon at the end of a line? Would you hold them accountable for that? Because they didn't see the output before they were able to run that when they submitted their exam. So we encourage our customers to make sure that this concept of multiple attempts is worked into the concept of auto grading as well. And I'll show you what that looks like in the product when we get to it. Okay, what does that bring us to? Well, I talk a lot about MATLAB every day. MATLAB is the language of technical computing, developed by Mathworks. Scientists and engineers worldwide are using it for very, very complicated projects in industry. MATLAB Grader is simply put our branded name for the auto-graded solution if the programming assignment is in the form of MATLAB code. It is not what we would also call an agnostic auto-grader. There are some other auto-grading solutions in the market that claim to work with any programming language in the world. We are not that. Mathworks makes MATLAB. We support MATLAB. We want to make sure that if you're teaching a course that uses MATLAB, you're using the best auto-grading solution possible for MATLAB. So it's sort of a tool fit for purpose. But conceptually, everything I talked about earlier, which was really about the theory of auto-grading, is totally baked in here. And we pride ourselves on trying to solve for instructor workflows. In this case, we're solving for the workflow of automatically grading student work and providing feedback. The other thing that I want to point out about MATLAB Grader is we designed it as an entirely web-based application and tool, but we also recognize that you may have your own learning environment. You might be using Moodle or Canvas or Blackboard or some other solution as your learning management system. And we want to make sure that the product works in that environment. And so we put a lot of effort into making sure we can integrate within the context of your learning environment. We'll be doing some demos of that today. All right, so who benefits? So we talked about why you would want to do it, but there's other types of people that this impacts. Starting very earlier in your instructional design process. If you again have the luxury of working with instructional designers, or you as a faculty member yourself are doing the act of instructional design, and you're building your own assessments, you can create, and I'm using this term very intentionally, the actual, the theoretical term of authentic assessment. So using an assessment environment that feels like a real experience that the learner might have when they're doing their occupation or their career. So it's the actual activity of programming is happening. It's not an abstract version of that, like writing code on paper. You're actually programming and getting real-time feedback in an environment that you're familiar with, and then you're reacting to that. And then we also ship with our product. You're not on your own. I mentioned earlier that there's this investment for creating these assignments up front. We understand that there's a bit of a burden to that. We also have off-the-shelf content, examples, training, resources. We're going to be talking a lot about the support you get from us for free to help you building your assignments. And we want to help you accelerate your online course development. Case in point, March of 2020, pandemic response teaching in full effect. MATLAB Grader was a key cornerstone for our customers to be able to bring their traditional courses online in a hurry. We had people that were going from traditional in-person instruction to fully online, had to convert their first week of assignments, and they were able to do it in a couple of hours using our product. And those were assignments that already were based on MATLAB, but just to convert them to auto grading. I mentioned earlier, for instructors, the big benefit here for MATLAB Grader is if you're teaching a large course. Large means different things from different people. I'm going to say 50 or more students. If you're teaching a course that's got 50 or more students, you're going to love this product. If you're teaching a course to 5 students, you're going to love this product. But the impact to you is going to be much more profound when you see how much time you'll be spending on other things. And I mentioned earlier, you can use these assignments for anything: practice, homework, exams, formative assessment, any type of assessment. I'm going to answer a question. Mohammed Fahad asks, how is MATLAB Grader applicable for theoretical assignments, i.e. non-mathematical and non-programming coding assignments? Great question. If you can express a theory in the form of MATLAB code, we're a good fit. One example I'm going to be showing you is we have a toolbox in MATLAB called the Symbolic Math Toolbox, which is really good for solving theoretical mathematical equations or systems of equations, and doing it symbolically. And so it's very powerful for teaching calculus or other math, but it's all just the code is expressing equations in the form of our MATLAB code, but it really is just math theory. So we'll talk, you'll see some links coming up here about some of our example content. When you see those links, explore that. Look at other types of content, other examples, other things other teachers have done with this product. I'm always impressed by what our instructors do with the tool. It's a very good general purpose tool. And then our instructors in our faculty community bring that to bear on their issues for whatever their academic discipline is. So my short version of my answer is, yes, it works for both the items that you described, but take a look at what we have, and then maybe we could do some examples with you on that. Teaching assistants, graders, other support staff you have. I like this equation: less time spent grading code it gives you more time to have contact with students, more office hours, more troubleshooting their solutions, more, hey, well, let's talk about the inputs to a function. Let's talk about argument validation. Let's talk about all, case statements. And again, let's reaffirm the learning objectives. Let's reaffirm, the prior class's skills, because it looks like we all haven't mastered that yet. It gives you that opportunity because you're going to see the real-time output from the assessments, and you'll have more time to respond. Sometimes you go through and you do all your grading and say, oh my gosh, that was terrible. We have to go back and revisit this content, but you've already blown 2 weeks, doing the grading activity. You don't have time to revisit the content. So we hope to give you that time back. Students, learners, those folks get immediate feedback so they can faster master those MATLAB skills and concepts. Very straightforward. Who's benefiting? Okay, so how do you do it? This is your pretty simple 4-step process here for implementing MATLAB Grader into your learning environment for your students. The first thing is converting your existing assignments over to the auto-grading solution format. Again, that's probably the most of the time you're going to spend. If you are brand new to using MATLAB in your classroom, you could start day one creating brand new assignments to your classroom. We add MATLAB into courses all the time, or maybe it was taught with a different programming language, or maybe there's a new course that's starting up that hasn't been written yet. Starting from day one with an auto-grading solution is a really great way to bring your course to your audience much more quickly. Also, providing students with practice problems. I like to refer to this as flashcards or reinforcement learning. That type of with students to say, look, this was the learning objective. Here's not just one, but here's 10 problems that reaffirm that concept. Feel free to practice with them in the learning environment and use that. That's a really great way of helping students refine, hone, and master skills. Don't just give them one problem because it took a lot of effort to create the handout and everything, and it's a lot of time for grading it. So you can't give them 50 problems because you don't have time to give them feedback on 50 problems. With MATLAB Grader, you could give them 50 problems to further practice because you don't have to spend the time giving them 50 responses. So it's another way of scaling your impact for learning is give them more materials because you don't have to spend so much time responding. You can use MATLAB Grader in a flipped classroom model. You can use it for active learning. where you've got the TA over the shoulder with a student. You could use it for pair programming or peer programming in class, and that's important. So if you wanted to actually do projects or things in the classroom with advisors and educators with the students looking at the work, flipped classroom really comes to mind. It's really great for that kind of a model. We actually have a lot of user stories that talk about how people have flipped the classroom, where MATLAB Grader in the class session was the way to learn. And then what we ship with, we don't want you just to do all this assessment and then not have tools to look at the output and the data. We also have built in a lot of different ways of viewing the performance analytics on those learners, both in our product and to export the raw results, the actual solution code itself, if you wanted to run it into other tools beyond ours, or if you just want to look at the statistics of the response rates on your assessments. And that can be looked at both at the individual student and the aggregate cohort level. There is a lot of published research. If you do a Google Scholar search for MATLAB Grader, you will see A/B tests. You will see comparative studies, longitudinal studies of the introduction of MATLAB Grader as a replacement for other techniques for assessment that validate that using auto grading with MATLAB Grader is as good as, and in most cases, better than traditional methods for programming assignments. These numbers are just a start of that. I have the privilege of looking at usage data to see how many people are getting a positive experience using this product. But don't take our word for it. Look online at the user stories. Look online at the published research. We also integrate with textbook publishers that actually integrate our methodology into that. So learn from others. While I technically am in marketing at Mathworks, as you can probably tell from this tone of this presentation, I love to put faculty in touch with other faculty and then talk amongst themselves to see if this is going to work. This is just some ideas about how you could use it. There's plenty of other ways of using the product as well. Okay, so I'm going to come back and say, what types of academic disciplines is MATLAB Grader useful in? You tell me. I have yet to find an academic discipline where programming as a skill is needed as a prerequisite or is developed as a co-requisite where MATLAB Grader could not be effective. On our website, this is another QR code here, you can browse the existing content collections that we have for off-the-shelf assessment content. We are delivering more of these all the time. As you can see here on the screenshot, I think when I took the screenshot, we had calculus, digital signal processing, dynamics, a general intro to programming, which covers very basic techniques for programming, numerical methods, which it covers statistics, symbolic math toolbox. That's what we talked about, the theoretical type assignments where you're doing a system of equations and solving them symbolically, system dynamics and control, which is really big in robotics and mechanical engineering, electric circuits, near and dear to my heart. If you want to know how to do a Thevenin equivalent in MATLAB, we can show that to you and how to measure the students' mastery of those concepts. And then we actually have a dedicated package of content on statistics, as well as examples that just show you how to learn how to use MATLAB Grader as an instructional tool. We have content and training for you as educators as well. This is just off-the-shelf assessments you could use as is to teach your students if you happen to teach these concepts, or use them for inspiration. Look at them, look at the examples. Oh, that's how you solve, a system of equations in that concept. I do systems of equations, but for chemistry, I can transfer that knowledge into how I do it. And so you can learn from these collections. So I encourage you to check that out. All right, so let's talk a little bit about integrating with your learning management system. MATLAB Grader is a web-based application. And we have a website that you can go to that we'll be doing a demo of today, where you can just log in with, we call it a Mathworks account. If you go to grader.mathworks.com, you can log in and create an account if you don't already have one, jump right in, start creating content today, and then run that on our website, which is great. We provide the whole learning environment. We provide, you can upload a course roster of your students. They get invited to enroll in the course. And we provide some reporting, and you can export the grades if you wanted from our system. But if you're teaching those very, very large class sizes, you probably don't want to spend any time doing enrollment management, where you're uploading lists of names. You probably don't want to spend any time exporting grades and then having to re-import them into your learning management system for reporting for accreditation or to your department anyway. So outside of just the time you'll save grading the actual code, we have other features available where you can integrate our auto grading experience into your learning management system. And we use industry standards for that. The most obvious one to use in this use case is something called LTI, which stands for Learning Tool Interoperability. It is the standard that learning management systems use to bring tools like ours into those environments. The QR code here goes to the page by the for the nonprofit organization that actually develops these standards. We're an affiliate member. We actually co-develop the standards as well. We roll up our sleeves and provide feedback on the standards. We are very knowledgeable about your learning management systems. Sometimes I find that we know a little bit more about the LMS than sometimes your administrators do, which is good for you as an instructor, because we come in and say, no, this is how you do it. And that link, you as an instructor may not need, but if you want to start, if you like what you see today, by the end of the demo, I think you will. If you like what you see, you're going to want to start to have a conversation with folks inside your university saying, hey, can we do this? Links like this, these QR codes you're going to see on the next couple of slides, are information for your IT staff and your learning technologists to help them understand how to bring our auto grading experience into your learning management system. And we are one of many products in the market that do this. The reason I want to bring this up for you is sort of a challenge response, going back to the theme of this conference for today's webinar. There's a challenge you have as an educator, which is you have a lot of teaching tools that you use to deliver your instruction. You probably are working with technology from 5, 6, 7 different vendors at a minimum, between your collaboration tools like Zoom, your discussion forums, your learning management system for your gradebook. When we introduce yet another tool to the equation like auto grading, you're going to want that tool to live in the place where you as an instructor are interacting with your students every day. We don't want you to go to yet another website. We don't want your students to have to remember yet another username and password, right? We want them to live and work and do their assignments in the learning environment you already direct them to every day. LMS integration is the way that works. And we want to make that easy for you. We don't want you as an instructor spending any time worrying about your learning environment not meeting your expectations. So we've done that work, and many vendors do this work. So we go through a rigorous certification process. The certification process checks out the technology, but it also checks out our data privacy and security standards. And we have a lot of transparent information on our website about that process. We also want to make sure that you know that we support your specific learning environment. So we have gone to the vendors themselves for your learning management system, and we have created integrations based on these standards. So we show up in your app stores. If you go to Blackboard, if you go to Brightspace, if you go to what's called the Edu App Center, which covers Canvas and other open source learning management systems, and you search for MATLAB, you will find us. And you will have a button you can click to start the process for onboarding the product into your environment. We want to make it that easy for you. And so these screenshots here with these codes are really for the people that will do that process for you. You could look at it as well. You can learn about the information. It might be, not your skill set to understand it, but it will help inform you to have a reasonable conversation with your IT and support staff to then bring that into your classes, into your learning environment. We promote the LMS integration pretty hard because we strongly believe for the learners, it's a better experience for them if they experience auto grading in the context of everything else. The context switching between different tools and services, it will impact the learner's ability to stay focused on the learning materials and the objectives and the skills that you want them to practice. Okay. I know this is a global event. I would be remiss if I did not at least address, and I'm surprised the question hasn't come into the chat yet, but I'm sure someone was thinking about this. What about privacy? What about security? Mathworks is a company headquartered in the United States. We have 14 offices, 14, 15 offices worldwide, thousands of employees. But what is Mathworks doing with respect to student data? What are we doing in terms of where does that data live? What data do we need to make this work? This sounds fun and will be useful, but really what's it going to take? Because the number one question your IT staff should have, probably will have, is, what does Mathworks do to protect student data privacy and security, and what is it doing? What information does it need to make this work? And so I put this little block diagram together. If you're more focused on the teaching and learning side and you don't really care about how the technology works, you can check in again in about 5 minutes, but it won't take that long to get through this. So I want to just also introduce you some concepts here. We're a tool provider. Mathworks makes a product called MATLAB Grader. We host it on Amazon Web Services. We've got servers in the United States and the European Union. You, the university, your IT staff, you may have your learning management system hosted on premise, or you might work with a vendor that's local to you. And your students or teachers are logging into that environment. All right, that's where you're going to start. But the assignments, the actual artifact that we're going to create today in our demo, the actual programming assignment, the content, what you write as an instructor with a problem description, what to do, how it's assessed, the assessment objects, you're going to create those. Those live in our servers. However, when a student logs into your learning management system and clicks a link to that programming assignment, we don't need a lot of information from the university about the student to set that up. What's really cool is these standards that we use automatically generate abstract identifiers for the student. And so we never see their name. We never see their email address. We don't know who they are individually as a person. We don't have any access to any other academic records they have. We just know that they want to access this assignment, and we get an identifier that we know if they came back to access the same assignment again, we know to let them restart where they left off. And the standard has some security, making sure that the only people that can launch the tool are licensed people from a university. So that's all we ask for. Nothing personal, nothing identifiable, nothing that would require a security review because of GDPR if you're in the European Union, or any other local or regional state or national laws about data privacy. They don't tend to get tripped up by our implementation. We do not collect names and email addresses. Now, we then display that assignment in your learning management system in like a little iframe. You're going to see what that looks like. And then the students can solve the exercise. They can write their code in a window. And when they're done, they hit the submit button, and it generates a solution that gets sent to our servers to be checked in real time. And the MATLAB service, an instance of MATLAB gets fired up. It runs the code, it generates the output, it does the assessments, it then generates a score. And it now knows that for that assignment, for that solution, there is a score associated to that anonymous person. We then post that grade back directly into your gradebook. And then it's gone. And so we don't keep rosters of students. We don't keep personally identifiable information on students. We don't need it. We are singularly focused on the task at hand. And this, I hope this is refreshing for some people when you talk with learning technology companies. Another challenge we have is we love all this technology. People are doing wonderful things for teaching and learning in academia, but they ask for a lot of information from your students to be able to deliver those services. We are not that. And in fact, we are very transparent about what we do and do not do. I have cited some of our privacy policies, so you don't have to read the whole thing, but if you wanted to, you could. I also have cited what we have. We actually have created what's called a trust center. That QR code will bring you to our documentation. And what's really cool, as instructors, when you talk with technology staff, your universities probably have a whole stack of paper that they make your tech vendors go through to allow them to connect in this way. We've been through that process so many times. A lot of that documentation is already on our website. So you can request copies of prior documentation so that your process, your ability as an instructor to get using our tool is that much faster. We find that working with IT staff and security can sometimes be an onerous process. So yeah, let's talk about another challenge you have as instructors. You see wonderful learning technology, but it's really hard to implement in your environment because working with your IT staff is a burden. or potentially you have a strained working relationship with them. I'm being very polite. Sometimes we don't like our IT staff. Sometimes we love them very much. Sometimes we find people that we work well with and we want to work with them some more. Mathworks is your partner in this to make sure that we can work in the context of your learning environment and get you as an instructor up and running as fast as possible. And so we've done a lot of work. If you take nothing else from this slide, saying we've been there before, it is not new to us. We are committed to making you successful. All right. Another way we are committed to making you successful. If you know what MATLAB is, if you joined today's webinar because you recognize the name MATLAB, you probably use MATLAB versus other programming languages because of the quality of our documentation. We're pretty proud of it. It's probably better than anything else in the market in terms of language support. Even open source products can't really compare to the quality of our documentation, our examples. The documentation for MATLAB Grader is no different. It is fantastic. This link will actually go right to our documentation site, so you can actually learn not only about how to use the product, but I've included a screenshot here for your learning management system staff or your IT staff, for them to know how to actually turn the product on in your environment. So we have documentation for you as an instructor. We have documentation for learners that are going to use the tool to understand how to actually solve the assignments. We have documentation for your IT staff to help them implement the product in your learning management system. We've got a lot of good documentation, and we have good training and support resources as well. We'll talk about that. So training videos, how-to videos, and other things to help you understand how to make the best use of the product. But don't take our word for it. The other thing we have on our website, and this QR code will actually go to the user story, they're called, for our customers that have actually used this. Virginia Tech, very world recognized university for engineering education in the United States, uses MATLAB Grader not just in one course, but as a prerequisite for multiple departments and degree pathways, and in multiple courses along those degree pathways. Aerospace engineering is an example. MATLAB Grader is probably used in like 4 or 5 or 6 different courses on a degree pathway. And the reason that's important is students become familiar with the tool early on in their introductory programming courses. And then when they see the tool used again in their more advanced level courses in their degree programs, they're familiar with the concepts, they're familiar with the user experience, they're familiar with what it's like to be assessed in this tool. Consistency in assessment methodology across the degree program or across multiple degree programs aids in program evaluation, it aids in accreditation, it aids in student experience on the form of assessment. It's why you might standardize on certain quiz tools or other learning technology for assessment. MATLAB Grader is no different, particularly if you're in an engineering discipline. You're probably going to be using MATLAB in multiple courses. Why don't you use the same assessment tools in all those courses? And so this is an example of how that's been done. The student quote here, "I live for green check marks." What you're going to find in our product is when you get the assignment right, there's actually some really nice gamification elements in here. One of the ways that we've responded to the challenge of getting students engaged in the active assessment, which is sometimes can be kind of a droll, boring, and tedious activity, is to borrow elements of gamification. I'm a gamer myself. I love being incented to complete things. I like the iconography of winning versus losing. And in MATLAB Grader, you're going to see some of that as well, this gamification approach. Does MATLAB Grader have the option to check for plagiarism? Aha! I'm going to answer that in my demo. Short answer is we provide the ability to export any student solutions or all student solutions to be used by a third-party plagiarism detection or academic integrity tool. Or the one that we see used a lot is there's an open source tool called MOS, Measure of Software Similarity, which comes from Stanford University. And we find that people basically can export the data from our product directly into that tool, and it's quite seamless, actually. We are always listening to our customers, and we've thought a little bit about doing some machine learning type methodology for plagiarism detection. We're working on research in that area. We're working with partners on that area. Our feelings are we don't want to bring our own feature to the market until it's as good or better as what is already out there. And for right now, we tend to make a reference to using MOS. And the good news is our product integrates with it so nicely, it's almost seamless. So if you have a requirement to do academic integrity checking of the student solutions, you should be able to use open source tools in collaboration with our tool to do those activities. And I'll show you where to get to that. Another user story, if you use MATLAB for programming assignments, likely you're using MATLAB or our other products for other aspects of science and engineering education. The good news is that MATLAB Grader works well with all those other products. It supports the same files. It supports the same plotting and visualizations. It supports the same programming techniques, the coding, syntax highlighting. It's all the same and consistent. So this is a really great user story because MATLAB Grader was part of multiple tools being used in the context of a learning management system. In this case, it was Canvas, and it was all the tools working together that was really the value proposition. We weren't just layering MATLAB Grader in, alone in this case. They were sort of, what I would say, all in on our other products for teaching and learning. And so check that out. If you are teaching a lot with MATLAB and you have a lot of project-based learning with MATLAB, MATLAB Grader is a really nice layer into that existing work you're already doing. Okay, so we're getting ready to do a demo. I'm going to set the stage for the demo, talk about what we're going to do in the demo, and then for Professor Adin, I think now would be a great time to take a break, where if we come back, we're going to talk about the scope and scale of the demo, and then spend the second half of our time today in product. So I think now is a great time to take a break.
Yeah, thank you, Alderson. Maybe we can have a break of about maximum 10 minutes. If anybody has any question, please. We have already received 2 questions. If you have any more question, you can very quickly type in the question box in Vertex.
Great. See you in 10.
Mr. Mohan. Hello. Hello.
Okay, we have been learning a lot from Jeff Alderson about the wonderful tool for auto grading the assignments, about the privacy issues, how it is resolving the privacy issues, how the platform is actually working, and also the possibility of utilizing it for even for non-mathematical assignments, as one of our attendee has asked. Let's continue our learning from Jeff Alderson. Let's start again. Okay.
Great. Thank you, Professor
Yeah.
Dean. So where to pick up? We should now go right into an actual demonstration of the two workflows that are part of auto grading. There's the instructor side and the student or learner side. It's the easiest way to split it up. This slide illustrates for you all of the different components that an automated programming environment can and should provide. MATLAB Grader does all these things, but if you are comparing MATLAB Grader to other auto grading solutions you may already be familiar with, and there are some in the market for other programming languages, you should see some consistency in approach. And you might find there's some things that we do uniquely, particularly how the learner can develop their solution in our desktop tools, like our IDE for MATLAB programming, and then transfer that information into the auto grading solution. We'll spend also some decent amount of time looking at results. I think I've got some demos and some examples here with some actual response data. It's all the demos I'm going to show you are all synthesized. They're all illustrative purposes only, no real students. But you may see as we scroll through some of the demos here, example course names and just to illustrate different disciplines we work in. But I'm only going to be going in depth into demos that are purely anonymous. And so when we look at the data, it's people either that work at Mathworks or sample data we've created through use of the tool. And I say that only to say, like, don't be spooked by some of the data you might see today. But we will be showing a lot of the analytics sides of things, how to see reports on the student submissions, including some really cool features like a solution map where you can actually plot student responses against each other and visualize, who's getting the concept well, who's writing efficient code, and those sorts of things. So that's the general workflow. For the instructor side, we're going to create something. We're going to create an assessment. We're going to create one from scratch. We're also going to create one using the off-the-shelf content we talked about earlier. We also are going to show you how to collaborate. You are not alone in your instructional design process, so you're going to want to have more than one person working on developing content. So we're going to show you how to do that. We're also going to show you how to enroll students in the version of the platform that we host on our website. Then we're going to switch gears, and I'm actually going to show you the student workflow. I'm going to actually have the student try to solve some of these problems we created. What's really cool is if you're following along, there's a point where you may want to enroll yourself in a course. And so I'm going to put an ask out here right now. It's a little different than Q&A, but if there's anybody on the call who might already have a Mathworks account, may already be teaching with MATLAB in their classroom, and would like to role play a student, if you could identify yourself in the chat and give us your email address, and sorry, in the Q&A, and just identify yourself as you would like to role play the student. In my demo, I will see that if you're interested, and as long as you're okay with people seeing your email address in my live demo, that's the other caveat. People will see your email address, so only volunteer if that's okay with you. If not, I'll use my own demo stuff. But if you'd like to see it, let me know, and I'll use a couple of examples and enroll you as students, and then you can see your results in real time as we're working on things. So that's an opportunity there if you're paying attention. And then we're gonna run those solutions through MATLAB Grader. We're gonna get some automated feedback based on the assessment tests that the instructor designed. We're gonna iterate on those solutions. We're gonna correct things. We're gonna resubmit things. We're gonna see what that looks like. And then once I've submitted enough data, then we're gonna use some reports. We're gonna look at comparing student solutions. We're going to look at as a student, the history of my solutions over time. Am I getting better or not? And then at the very end, we're going to go back to the instructor view, and I'm going to show you how to take all that investment we just did of creating the content and just drop it into my learning management system. So I'm going to show you what that looks like in the context of one of the most popular learning management systems, which is the Canvas LMS by Instructure. We're going to use that for our demo today. And in that case, I'm going to show you a live course I'm working with, and we're going to drop in some assignments we've already created, as well as show you how to create a new assignment there as well, and then show you some of the nuance of what the power is once that auto grading is in your LMS. What LMS features now really start to shine, because you can start to look at the gradebook history for auto graded assignments. That's the scope. So that sets the stage. And here we are at 2:06. We'll jump right into it. So I'm going to show you two views. I'm going to be using two versions of the product. One is what we call our hosted version, which is at grader.mathworks.com. That's that QR code there. If you just go to mathworks.com and search for Grader, you'll find it. If you actually just search for MATLAB Grader on Google, you'll find it. It's a relatively simply named product, so you should be able to find it. But that's our hosted version. We're going to start there. And the reason I start there is because if you're an instructor and you're collaborating with a lot of other instructors, you can think of that version of the product as sort of your content authoring studio. That's where you're going to create your content first. You're going to develop the content. You're going to test the content, make sure it works. And then once that content is done, you have a choice of where you're going to run your assignments. You can run them on our website at grader.mathworks.com, where you'll use our site for all the enrollment management. You'll use our site for all the grading and reporting outcomes, or you can then pivot, log into your learning management system, and basically drag and drop those assignments into your course syllabus and leverage the LMS for enrollment management and for reporting and analytics. We're going to show both models. Okay. So this is the point in time where I'm going to stop sharing. I believe that's where I'm at. Yeah, I'm going to stop sharing my slides, and we're going to jump right into the product. So this is MATLAB Grader. MATLAB Grader is a responsive web-based application. What does that mean? We are big into accessibility. If you are teaching at a university, and I think everyone is these days, where accessibility for students with disabilities is important to you or required by your university by policy, we have a mobile responsive design. And you will notice I'm just going to use my keyboard shortcuts to do this. That you can actually change the font size and pitch. And you'll notice that the menu is at the top. The navigational elements change based on the resolution and the settings of my fonts. Also works on mobile devices. I will give you one caveat for that. Works really great with iPads or tablets or anything with an attached keyboard. This is programming, okay? Programming on an iPhone with two thumbs, possible. Better these days than it has been, but you're probably going to want a keyboard to type any amount of programming script. So strongly recommend tablets and keyboards, although the responsive design does let it work on any device. So I'll put that out there. The navigation, just to give you some elements here. So I am logged in with a Mathworks account. That is our general profile you use for accessing anything Mathworks related about MATLAB or any of our other products. So as long, some of you, if you're teaching with MATLAB, you probably already have a Mathworks account. And so using that same account you already have, you can log in and use our product. MATLAB Grader does require a license for the instructor, meaning a MATLAB license. So if you're an instructor and you're at a school that teaches with MATLAB, as long as you are associated to a license for MATLAB at your university, and you can get that a variety of ways. We're not going to talk a lot about licensing today. I want to talk about the tool. But if you have questions about that, you feel free to put them in the chat, and we'll get around to that. Or at the end of the presentation, there's some links to ask questions about licensing. But as most people that teach with MATLAB have access to a license for MATLAB. The other good news is your students don't need a license. So you could actually teach how to program in MATLAB, and the students do not need a separate MATLAB license, which is actually very powerful in schools and universities that are budget constrained. And while there are universities that might have purchased licenses for their students, or they might ask students to buy their own license, we recognize that not every student can have a license in all cases for the teaching aspects of things. So as long as the instructor is covered by a license, any student that they invite to a course running on MATLAB Grader can use MATLAB Grader without needing a separate license. That's important. So what else do we have? You'll notice here, I have quick access to any other products, training, help, files, videos, submitting bugs if you find them. You're one click away from getting any access to our documentation in the product. And so again, we pride ourselves at Mathworks about our community, that there are millions of MATLAB users worldwide, and you're benefiting from being a part of that community, even with our teaching tools. And so that's there for you. Specifically to MATLAB Grader, though, there are things that we have created to help you make use of the tool. There's a quick link to our documentation, which we talked about. That actually will open in a new tab here just to show you this is our documentation for MATLAB Grader. And then as I drill in as an instructor, you'll see that there's a lot of detailed information and instructions, videos about how to use the product. I won't spend a lot of time on the training stuff because you're going to get that firsthand from me, right? You're going to hear directly from the product manager how to use the product. So hopefully I represent the product well, and you can learn something today about it too. But failing that, you can always go to documentation and learn more about all the different ways of using the tool. Also in documentation support, we have a very short overview video, pretty much what you saw in the first hour, a very short version of that. It's great for a refresher if you want to tell colleagues about MATLAB Grader. I think the guided tour video is the way to do it. Definitely recommend sharing that with other people at your university. If you really want to have almost like what we're having right now, which is the second half of our workshop, but you want to also share that with other people in your community, we have a self-paced training course called Teaching with MATLAB. And 30 minutes of that course is dedicated to hands-on learning with MATLAB Grader. So you get a little bit of that workshop flavor in a self-paced teaching environment where you as an instructor are the student, all right? And so you're learning how to teach with our tools. And it's not just about MATLAB Grader. Remember that user story we talked about in the first hour. There's all these other tools we use for teaching and learning that are all complementary. And so the Teaching with MATLAB training covers all of them. And so you can learn about MATLAB Grader in the context of other things. If you want to know more about the product, all the great things I've been saying today, all the words I've been using about the research, about how the product is used in industry, if you want to make the case inside your university for why you might want to use this or invest the time into adopting it, all of our user stories, all of the information about the product are available on our website, and that's only one click away as well. Release notes, it is software. We have new features that come out all the time. If you know a little bit about MATLAB itself, we have new versions twice a year. We call it A and B. So right now we're still running 22A. I think 22B is coming up next month. And we do that like clockwork. MATLAB Grader comes out even faster than that. We have an agile development methodology. As we find bugs, we fix them. If we have new features, we roll them out as they are ready. And so every other week you might be getting new stuff in the product. And so release notes are a great way to check in to see what's new about the product. And then what you'll also notice here is tech support. MATLAB Grader has fantastic tech support because it's the same technical support for any other product that Mathworks provides. Mathworks is a global company. Your support will go to local staff and resources to help you directly. And there's escalation to product teams and other specialists, including folks like myself, to really get to the heart of any issues you're having. So if the product is ever not working the way it's supposed to, or you just have a question about training or how to get onboarding with your learning management system, you can start here. And anyone with a license can do tech support. Tech support's entirely free included. There is no limit to the support you can get. Even if you are an instructor just trying to ask questions about how to use it to teach in your course, we will answer those questions through tech support. Okay, so that's all the stuff that we also provide. The homepage of MATLAB Grader is very simple. It's broken into two things. There are the courses that I'm running. So these are the courses that I'm either actively teaching or the courses that have occurred in the past. And right now you'll notice in my past courses, these are courses that I am an instructor in, or I've been invited to be an instructor in, that have all concluded at some time in the past. And then there are the courses that I'm currently running that either have no end date, they're open enrollment courses that go on forever, or they will end at some point in time in the near future, until that I've got my current courses. And you'll notice that I've got a few of those courses lined up here. And those are courses that actually have real students enrolled, that are solving real problems, that are collecting real data, that have real reports and real grades. that are live, what I'll call live courses. And then there is this concept of content, which is basically repositories where you can create your assessments, have them under version control, collaborate with other instructional designers to develop your assessments, test those assessments. Maybe you use them last semester, but you want to make some modifications to some variable names, or you want to do some bug fixes. So you have this content, authoring studio built in where you can build as many content objects as you want, and then reuse them in one or more courses. And so for today's demo, that's where we're going to start. We're going to start by creating a new collection. I'm just going to call today is the demo. Today's demo, the date in. This is my local date, August. So that's going to come up. We're going to look for that date. I like to organize my content temporally, meaning for this collection, if I were teaching it in a course, here's what I might do week 1, week 2 versus week 3. You could also organize it by topic. So if you teach like control systems, you might want to organize, signals versus feedback versus, kinematics. You could do a lot of different things. And so you could organize it by any sort of group you want. I'm just going to take a very simplistic approach and create my first group. And a group is just really a folder called week 1. And I'm going to go ahead and create this. And what this has done now is it's basically created a container view. You can see the folder tree on the left. I can have as many weeks as I want. So I'm just going to go ahead and create more. And I'm going to add another one. This is what you might do is say you were creating a multi-week course and you wanted to organize all of your homework assignments by time. So that's what we're going to do. So this is going to be a 3-week course. And then I'm going to go back to week 1. And in week 1, you'll notice there's currently no problems for this group. A problem is the unit of work. It's the unit of assessment. You can have multiple problems that you can group together and assign to students, but the unit of work that you're as an instructor for creating assessments is called a problem. Sometimes it's known as an exercise, sometimes it's known as an assignment. And so in this case, we're going to create a new thing, and we're going to create this button to add a problem. And you'll notice you're given some options. You could create from scratch. So once you are skilled enough to call yourself a power user and you want to, just jump right into creating a new one from scratch, you know how to use the product, great, more power to you. Go right into creating a blank problem. I like to jump in and use an example. And you'll notice, remember we talked earlier in the first hour about all those great assessment content collections. This is where you find them. When you're logged in and you're looking at the examples, you might drill down and look at our intro to programming content, and you might find something about flow control, and you might find that you want an example of a simple if else statement. You can actually look for examples across common techniques in programming and use it as if. Or you might want to just your basics. Today is about just orientation. So we're gonna focus on a getting started thing. And we have some very simplistic examples that show you how to do very common things in MATLAB Grader. How do I do scripts or functions? How do I, and some of these are actually, strongly typed to certain academic disciplines, right? Some of these are around climate data, some of these are around robotics, some of these are around electrical engineering. And so the examples are from real problems that we've seen our instructor community use. But I'm just going to start with my first script. And my first script is sort of a very generic demo that shows all the features of MATLAB Grader. So it's really good for today's purposes. I could actually view the preview, what that looks like. So this is actually what it might look like in terms of the content. But since I know we're going to use it for the demo, I'm just going to click this button and copy it. And copy it brings it into my collection. And you'll notice now the title is now on the left navigation. It's highlighted. I'm now editing this problem. And notice it put it in what's called final mode, meaning it was off the shelf. It's ready to go. It's ready to be used. But you know what? I want to make some changes to it. So the first thing I'm going to do is I'm going to set it to draft so I can actually modify this and do some other things. And so now all the interfaces have now enabled, so I can make some modifications. You could change the title. You could change the description. This is what you see is what you get, a WYSIWYG editor. It supports equation editing. It supports text, images, code snippets. This is a version of, if you're a MATLAB user, what we call live editor. So you can actually copy and paste problem descriptions from your other live scripts you might use in MATLAB. So that's another great example of compatibility between our products. In this case, the problem is very simple. So I'm going to go back to what one of the questions that came in, like, what types of disciplines does this work in? Well, it really works in any discipline. In this case, we're just going to do some very simple, solids work. We're going to calculate the volume of a cone. There's an equation for that. It's given. We're also going to give the student the fixed values of the radius and the height of the cone, and we want them to compute the value of the volume and store that in a variable name called VOL. That's in black bold font. And then we are going to have them answer in the form of a script. And so as I scroll down here, you'll notice that we have two different types of problems. One is just script, like a code. It's going to run start to finish. We also have a type of problem that can be solved as a function, meaning the student is going to build a portable bit of code that's going to be called multiple times with different sets of inputs. That's more of a complex maneuver we're probably not going to get into today, but just to show you that there are different ways that students could solve the problem. In this case, they're going to solve in the form of a script. Then we start talking about what's called a reference solution, also known as a potential correct answer. I want to say very clearly, this is not the correct answer. This is coding. This is algorithm design. You can get to the right answer a lot of different ways. You can encourage your students to get there the way that you want them to by scaffolding your solution and giving hints, or being very explicit with variable declarations, or being very explicit about certain functions or built-in keywords you want them to use or not use. And so in this case, we're going to do a couple of examples here to show you how that's enforced. So this is this very simple example. This is the simplest form. There is a radius, there is a height, there is a volume. And if you know about the equation up above, this is how MATLAB could, one of many ways that it could calculate the volume of the cone in a mathematical expression. And this is a correct answer because down further, we have these assessment tests. And one of the assessment tests is to check that the variable called VOL is the same between the reference solution and what the student's going to provide. So the way MATLAB Grader works is actually very elegant, very simple, but very powerful. The first thing it does is it runs the reference solution, and then it gets an output. And that output could be multiple variables. It's got a workspace. Anything that was done in the script is available for assessment. Anything. Images, plots, figures, objects, structures, files. Then, so the reference solution is run first. Then the student solution is run. You get another workspace with all the same stuff. Then the assessment tests are run. You can have one or more assessment tests. You need at least one. In this case, all we're checking is that the value that was created for VOL in the student solution is the same as the value in the reference solution within tolerance. And now MATLAB is a numerical computational tool. Sometimes when you do numerical methods computation, you may get close to the same answer, but if you didn't use the same method, you will not have the same tolerance for your variables. So you can define what tolerance you want for correctness. In this case, we're using the default tolerance. And then if it doesn't pass, if for whatever reason this value is not found, or it is incorrect, or it is not within tolerance, an error will be thrown. And the error will give some feedback to the student. Now we're talking about that first slide I showed you today, getting real-time feedback to the student. And so in this case, the feedback, if the assessment fails, will be displayed to the student immediately. And they'll be able to see the feedback. This is optional. You don't have to give feedback at every time. If you don't give feedback, excuse me, the student will know that the assessment failed, but they will not know why. They will also be able to see the output of MATLAB. This is a MATLAB script. It's going to make MATLAB do things. We will show them the raw output of MATLAB, but we will not explicitly tell them why the assessment test failed unless you, the instructor, tell them yourself. And so some auto-grading solutions do more or less of that. We have taken the firm line that we do not want to interpret correctness. We want our faculty users to explicitly define what makes code correct. And so part of learning how to use MATLAB Grader comes down to you enforcing your policies, your rubrics, your style, what is important to you in your assessments. So for example, this reference solution uses the built-in variable declaration of pi for the constant. I want to make sure that the student actually uses the built-in declaration of pi and not an approximation like 3.14159. So I'm going to add another assessment test and say, was pi used? And we're going to check for another test type, which is the presence of a function or keyword, and they must use pi. And if they don't use pi, I'm going to say, please use pi. Very simple. I'm being very reductive in this, but I want that to be part of the demo today. Just bear with me. This is an example, a very simplified one of a presence check for a specific keyword. And then the other aspect of this, I mentioned the learner's solution a couple of times. You could give the learner some hints. You could give them some starting code. You could also lock lines of code. So in this case, we've got some comments. So a percent in MATLAB is a comment. And then you've got variable declarations that are locked. And so in this case, everything here is locked except the last line where I want them to put their answer in. You know, in fact, I'm actually going to give them a hint of what the name of the variable should be. And so I'm going to basically hand them the solution except for them answering the final bit here. The next thing I do, because I'm developing this content, is I want to make sure that my solution passes my assessments, because the last thing I want to do is give the student something they can't solve. So I come down here to the bottom and I validate the reference solution. And the validation will then run all these assessment tests against my code. I'm suppressing output in the code, so it doesn't actually run anything. And you can actually see here that the two assessment tests that I developed passed because my example reference solution conforms to that output. Now, I might want to test breaking that with some scenarios. So I'm going to preview what this might look like to the learner. And so with a button click, I can now jump into the learner mode. And so now we're on that different part of the workflow. Remember I said I was going to show you a little bit of like what the student would see versus what the instructor sees. So now I'm seeing what the student might see. And what the student sees is the question, the title, the prompt, all the same content. And then when they get to their script box, all these lines are locked. I can't modify them except for this statement. So I'm going to try to answer this. First thing I'm going to do is I'm going to try to solve it by saying it's equal to this value times the radius times the radius times the height. I'm going to make a mistake. All this divided by 2. That's a really simple mistake. And I'm going to run my script. I have not submitted it for grading. I'm just going to run it because I wanted to show you that the MATLAB output comes out in real time. And what just happened when I hit that button is it went to the cloud, it went to our server, it took the code, it ran the code, it got the results back, all in real time. So I got the MATLAB output in real time. I didn't have to open up MATLAB and run it. It's all doing that for me automatically, which is another great thing you don't need to worry about as an instructor. You don't need to worry about getting MATLAB to work on the student's machine, which is its own thing. So you just point them here and all the MATLAB is happening on the back end, which is great. But now I think I've got an answer. I want to run this for assessment. I want to see if my submission is correct. And now I submit it for grading. Now, what's really cool here is 2 things are going on that are wrong. Notice that both assessments failed. Notice I had created custom feedback for the first one. And so it's saying, well, the volume is incorrect and pi was not used. Oh, I didn't know I had to use pi. I have to change that. So now I'm going to come up and I'm going to change my solution. I'm iterating and I'm going to submit it for regrading. And lo and behold, pi was used, but now the volume is still incorrect. Okay, so I read the equation. I check the question prompt. Oh, it's dividing it by 3. Oh, I'm going to divide it by 3 instead. And I'm going to resubmit for grading. And now I have all the tests passed and I see my output, which is correct. So this is very simply put what's possible. The rest of this is really up to your imagination. And so, you can repeat this process as many times as you want. And you'll notice it's very simple. I can create as many, examples as I want under each of these weeks. I could have it in escalation of difficulty. I can group it by topic. I can do whatever I want. And then I've created all this content and I've stored it. What I'm going to do right now is I'm actually going to say, you know what, I'm actually not going to create any more content. I've already created this item. I'm now going to save this as final, which also validates it to make sure it will still be solvable by a student. It is now locked down. So this is now final. It is now available to learners that I could put into a course. So now I've created the content. I want to check this with another instructional designer on my team, or I want my teaching assistants to review it. So I'm now going to add someone else to participate. And in this case, I could add somebody else in here to participate in this course. I didn't see any emails being passed in. So basically, you know, you could add anyone else in that you know that might have an account. So I'm just going to choose a colleague at random. He's going to get an email here in a second. But I'm enrolling Bradley as a instructor in my collection. And what this means is we now have equivalent capability to collaborate and edit this content. So if you're working in a team with teaching assistants, you as an instructor could create some content and then tell your assistants just to keep creating content. And you can add as many as you want for instructors. And now we all have equal access to be able to use this content. And so if Bradley were to log in and create a course, he could use content that I've invited him to see. So if you need to pass your content on to another instructor after you leave the university or you're no longer teaching that course, it's as simple as just inviting them to your course. Okay, so that's content collaboration in a nutshell. So now I'm going to go back to my homepage. The next thing we want to do is we actually want to create a course, and I'm going to do this very quickly. We're going to create a course in, so what are we in, UTC? And we're going to go UTC -2. Yeah, I'm picking something at random here. This course is going to be the 12 August 2022 demo course, just to give it a different nomenclature. It's going to start, let's say it started yesterday and it's going to end tomorrow. That'll give me some time for it to run up. MATLAB, not only are you having access to MATLAB, if you know a little bit about MATLAB, you have access to all of our products as well. So if you're teaching a electrical engineering course that requires digital signal processing, you could choose our digital signal processing toolbox. And there you go. I'm not going to put any sort of description in for the course. I'm just going to create a title and name it. And now you're going to see something that looks very familiar. On this left nav, I've got assignments. So what I'm going to do is for let's going to call this week 1 programming exercise. It's going to be visible to students. Let's say it was visible yesterday. It's going to be due by the end of the day today, later on this evening at some point. And you can limit the number of submission attempts or not. So by default, it'll be unlimited attempts. So you saw I iterated 3 times before. I can have those number of attempts. You can also limit it if there was a use case for doing it. I would say probably it's because you don't want students to spend more time bashing their head against the solution before they move on to the next item. So it's really just a peace of mind checkbox here that you could limit the number of attempts to maybe 5. Okay, so don't try this more than 5 times, move on if you get stuck. And then once you've done that, you can save that. So this assignment now could include more than 1 item. We're going to add items to it, but it started yesterday, it ends tonight, and you have 5 attempts. So now I'm going to add an item. And what I'm going to look for, and this is going to be really cool, is you can either choose those same samples you saw before, or you can choose from any course you've ever run using MATLAB Grader in the past on any system, any learning management system you've ever done. And so I'm the demo guy, right? So I've got a lot of demos, but I'm scrolling here, and eventually we will find, I'm actually going to search for it, 12 demo. So here is the collection that we created earlier. And so I want to reuse the content we created before. So here's the one I want. I'm going to copy that into my course. And now I am in my course. This item is now live, which is great. So what's missing? Students. Who's going to solve this? Well, let me enroll some students. So it's very simple. I'm just going to enroll some students. I could also enroll other instructors. So if I want to enroll Brad again as instructor, I could. For right now, I'm just going to keep giving him emails. I'm going to enroll that same gentleman as a student. And now you can see he is here enrolled as a student. And this could be a comma separated list. So if you exported a list from another environment or a registration list, you have it, you just upload that. And that's it. So now I can go back to the assignment and you'll see here some really cool things happening. This list will grow as I add additional problems to the assignment. This bar is interactive in the sense it will show you how many people have or have not solved or attempted this problem. As I click in, you will see that this is the definition of the problem. I have links to analytics to see how the class is doing. And I can look at the specific solutions by these learners. But because I just invited Brad, I don't have any content or any data yet. So I'm going to quickly jump over and pull up a course that already has some data. So I'm going to go to a workshop we did a couple of years ago. And a couple of years ago, we did this workshop at AAEE. You can see here that it had a lot of different examples, but they had a very similar problem, that volume of the cone. And people were saying, hey, you know, conference, take a look. Just this is a demo. So here's the answer. And so we gave it to them. And you'll notice here the bar at the top starts to fill in as people actually solve the problem. And so I'm going to go into this thing called class overview. And this is our learning analytics package that's built into the product. And it will start to show you that of all the people that are enrolled in the course, how many people have solved it versus how many have not. And so how many yet to attempt it. And this is real-time analytics. You don't have to wait for this. This is as students hit the submit button, this is updated in real time. And you can then start to see of the people that have solved it, how long did it take them to solve it? And so you can start to see the mean number of submissions, the number of submissions. So one person, 100% of learners took one attempt. Of the people that it solved, it took them one attempt. This problem has 3 assessment tests. The one I created as a demo had 2. In this case, this one has 3. And as you hover over, you can actually see the titles of the assessment tests. And you can see this, of all the attempts, how many attempts did it take to solve each assessment test? Why is this important? Well, when you're looking, I'm going to go actually back and look for some maybe some more complex data, maybe some real course stuff here. So I'm going to go to a past course and I'm going to find, yeah, this is one that's actually got some data in it. So I'm going to go into a previous course that's got some data, it's got some red, and I'm going to go to the class overview for this problem. In this case, I've got some folks that did not solve it. And what's really cool here is you can start to see why they didn't solve it. Where were they getting stuck? Well, there were assertion type errors as opposed to syntax, as opposed to runtime errors when trying to attempt to resolve assessment test 1. And you can tell here that of the people that got it wrong, one person tried it once and quit. A few other people, 2 learners tried it once and quit. 1 learner tried it 4 times and quit. And then there's still 91% of the class that did not yet attempt it. Of the people that did get it right, the vast majority of them took 1 attempt. There was 1 person that took 2 attempts. And then there's this poor soul over here that stuck it out. It took them 19 attempts to get the problem right. But on average, it's about 3.1 attempts to get that assessment test right. See how this is working? This is giving you some insight on a per test basis, not the problem, but the test, how it was working. But then you might say, well, I want to see who did that, who took 19 attempts. So you can go into the list of solutions, and you can actually see the code that was actually submitted. And you can actually see whether this was passing code versus failing code. What's also cool is you can go into what's called a map view. And these are the number of attempts left to right in sequential order, not temporal order, but sequential order. So this one came in before this one, and so on. Red X's, this is the gamification we talked about earlier. Red X's are incorrect answers, green circles are correct answers. The blue diamond, another aspect of gamification. This is the most efficient code written so far that got it correct. So in this case, efficiency is measured in code size, number of nodes, not number of lines of code, but number of nodes, or like compilation nodes. And you can see that some incorrect solutions don't match the normal pattern, right? A lot of people are in the same boat about it. Like, here's that guy that tried it 19 times before he got it right. You can see that there's a lot of people that get it right the same way. There's a lot of people that get it wrong the same way. So that's really interesting. And I can actually look at this winning code and see how they did it. And then I can compare it. How is that code different than this one? Oh, he's just computing the matrix completely the wrong way. And he's using the wrong call of converting that to an integer. So you can start to see patterns in the data as to why the students may or may not be getting this correct. Okay, well, this is great. Let's go back to answering the question that someone asked earlier. What about plagiarism detection? The code's correct, but if everyone's getting it correct, do I have a cheating problem? Well, programming code is interesting because it's not just about the code, it's also about variable names, there's white space, there's commenting, there's style. There's a lot of things that could factor into whether the code is the same code copied and pasted, or it's been modified. And you might want to check that for similarity. So what you can do is you can go back to the assignment, and one of the actions is here is a report. And what's really cool about reporting is you can focus on just the grading outcomes. So after the course ends, if you just wanted to get the solutions, the actual code output to a zip file, you could get that. Or you could just look at the result. So in this case, the CSV and the Excel files will put basically everything into one file. But what's really neat is if you choose MATLAB code files, here's that little keyword there, good for plagiarism detection. It will actually create a zip file with folders and naming conventions that really work well with MOS, so that it'll go right out to that plagiarism detection tool. You can do additional analysis on this. And you can run this through your gradebook and your learning management system if you wanted to manually import it. But that's where we're going to switch context. I know we've got about a little less than 20 minutes left, but I want to show you what this workflow looks like in the context of a learning management system. So let's talk about that a little bit. I have access to a learning management system. In this case, it's Canvas, made by Instructure. This is a demo site. I'm logged in as an instructor. Let's say, hypothetically, I'm teaching this Intro to Programming with MATLAB course, and I've already loaded some content from Creative Commons from our website. We have other resources for teaching. Beyond just auto grading, we have other content. And I've already loaded this in, and I'm already in the act of teaching. And so I'm going to go into my content that I'm teaching with, and I've already done some content here. I'm going to add more content to my syllabus for week 1. Well, remember we did that. We created the content in the hosted version of MATLAB Grader in that content environment. I just want to use that problem I've already created and just drop it into my learning management system, because my learning management system already has a roster of people. It already has a great gradebook for analytics. So I'm going to go ahead and add a new item here to week 1. So it's as simple as just saying I'm going to add a new assignment. I'm going to create the assignment, and we're going to call this the demo from 12 Aug 2022. And we're just going to add this to my module. That's just an LMS thing. That just got me started. So now I'm going to click on it, and we're going to modify the settings. And the first thing we're going to do is give it some points. It's going to be worth some points. This one's going to be worth 10 points. I'm going to group the assignment. I'm actually going to put this one into a group called homework examples. You could group your assignments any way you want. Some people like to group all the MATLAB stuff in their entire course together, so it shows up in the gradebook in a nice grouped category called MATLAB homework. That's a really good, great way of doing it. You could name it whatever you want to group it, or you don't have to group it. Just know that your gradebook's going to get really wide left to right if you don't use groups. But in this case, I'm going to put it in a group called homework. This is the important part. It's a submission type. Of what type? External tool. Well, the good news is my learning management system admin already followed the links I showed you in the first hour of today's workshop. They already did the work to add MATLAB Grader as a supported tool in my learning management system. So all I have to do is find it. So I click find, and then I'm going to go ahead and find the one I want. The latest version of MATLAB Grader in the learning management system is 1.3. So I'm just going to choose that one. Your LMS will probably only have one entry. I do a lot of demos, so I've got a lot of other stuff. So I'm just going to choose the one that makes sense. And that's it. Notice again, I'm just going to leave all the rest of the settings fine, and I'm going to hit save and publish. you will see an interface that looks very familiar. So this is what we call our problem chooser, and I can either choose an example, or I can choose any content that I've already created previously. And in this case, I'm going to do a little find of 12 OG, and there's my demo. I'm going to find that content. I'm going to copy it. And now that same demo problem is now available in my learning management system. And it's the same exact content with the same assessments we did before. And it knows me as the instructor because I've already linked my Mathworks account. Before, when I logged into the LMS, I didn't give you a demo of that. But basically what it means is when you log into your LMS the first time, it'll prompt you for your Mathworks account as an instructor. Have you already created, it'll ask you, have you already created content before? You probably want to reuse it, right? So log in here to reuse your content. You don't have to. You can create a new one from scratch, but you probably want to reuse the content. And so I just did. I already logged in. It's got the content waiting for me. I just chose it. I'm reusing it. Great. Now I want to see what the student sees. So all I have to do is go back into my modules. Notice that this is now published. It's available for students to work on. It's going to be worth 10 points. And now I'm going to go to the student view. I'm using the feature in Canvas to look at the student view. And you'll notice week 1, demo. I click on it and it launches. Notice as a student, it's the first time I'm used this tool or this product. So it's going to prompt me to accept the terms of use. It doesn't require an account. It's going to be very clear about, what the product does. This is something we can provide to you to review as well. I'm going to accept those terms of use. And now I'm looking at that same content. And because we all know the answer, say it out with me, pi times radius times height over. I'm going to get it wrong again, though, because I'm not paying attention. 2. Well, I'm doing this intentionally because I want to prove a point. It's wrong. I used pi, so I just got half of it right. I'm going to iterate on my solution. I'm going to correct it. I'm going to resubmit it. It is now correct. I can now go back to my assignments. And I can see when I search for the assignment, I'm going to search for 12 OG. Notice I now have credit of 10 out of 10 points for this assignment. The gradebook was told automatically when I finished the assignment. And when I come back in again as a student and I look at my assignments, it's still there waiting for me. If I go to my gradebook as a student, because I have it set to release grades automatically, and I look at the assignment group and I'm looking for those homework assignments, you'll notice there it is under homework examples, the demo, and there it is, 10 out of 10. That's it. I'm going to leave the student view. And now what I'm going to do as an instructor is I'm in the gradebook as an instructor. There's test student. I'm going to search those assignments again for 12 August. And lo and behold, I can see that test student got 10 out of 10. So the instructor can also see the same results. I'm going to go back to the syllabus as the instructor, do one last thing, and then we're going to wrap up for any open Q&A. We're going to go back to the list of assignments in my modules. I'm going to click on the item here. And as the instructor, you're now going to notice, I might not have it enabled for the demo, so this will be shorter today. I can always go back and make changes as the instructor. But if I have actual student submissions, I'll have a little button up here for reporting that'll show me the same analytics I showed you earlier. But that's really what we have there. And that's really it. So I'm going to jump back to our slides and, just confirm this, for me yourselves. If you like what you saw, try it out. It's free. If you're teaching with MATLAB, you already have the license you need. Just log in, give it a shot. Other professors like it a lot across a lot of disciplines. Peter Quirk, who's in Australia at QUT, uses it in all of his robotics courses. People use MATLAB Grader for the active learning labs and a lot of programming classes, and they find that the lab time is reduced because that consistency and that grading experience. They just knew the routine, they knew what to expect, they liked the look and feel. It gave them that automated feedback. They iterate on their solutions. They made better use of their lab time. We've got other testimonials on our website across the world. Tohoku University in Japan, MT Minis and I'll be in France. And so you've got people that are talking about Moodle use of MATLAB Grader. Every LMS you can think of is being used. So short way of saying, check it out for yourself, talk to your colleagues, look at research. It's being used quite a bit. I leave you with this. These are the last links and information you would need. Start today. That's the URL. That's the code for that URL. If you have any questions that I wasn't able to answer today, you can always go back and look at the product page and learn more about it. And if you want to use it, you want to get started, that's a link to our contact page to start the process, get in touch with folks on our tech support team to start the process to integrate. And with that, Professor Din, I am happy to take additional questions if any have come in, or see if anyone has anything specific that I didn't cover today.
We have received 2 questions that I think you have wonderfully explained to the attendees. And so far, I think more questions will be coming up. And as you have kept the scope open for asking questions. Anyway, I would like to thank Jeff Alderson for the wonderful demonstration and workshop about the MATLAB Grade. And I'm sure that the educators, the faculty members of the different universities and educational institutions, they will get the idea about greater possibility and newer dimensions, how the assessments can be automated, how the assessments can be made more effective using the technology, the educational technologies that you have demonstrated. So we can be really very hopeful about that. So can we conclude the session, Alderson?
Absolutely.
Anything more you want to? Yeah.
No,
okay.
Thank you for your time. I welcome future questions. My contact info is available to the attendees. Happy to answer questions in the future as well. Okay.
So thank you very much. Thank you very much to the attendees for joining this workshop session of the In4OBE Global Virtual Summit. And I also invite all the attendees to please review the agenda for other great presentations of the summit. Thank you very much.
Okay, sir, that was very informative session. The way you described the points were very impressive.
Sorry, Faizan, did you say anything?
I'm saying I'm ending the webinar.
Yeah. The webinar is concluded here. Thank you very much.